Hundreds of thousands of galaxies appear to be moving toward the same destination. The Milky Way is part of the flow. Entire galaxy clusters are part of the flow. Something appears to be pulling vast regions of the universe in the same direction. Something is pulling vast regions of the universe in the same direction. The problem is that astronomers cannot see exactly what it is. When researchers began measuring the motion of nearby galaxies, they expected to find a complicated pattern, some moving one way, others moving another. Instead, a strange alignment appeared. The behavior repeated across larger and larger maps. Entire groups of galaxies appeared to be heading in the same direction at speeds of hundreds of miles per second. That created an immediate problem. Motion on this scale does not happen without a cause. Something had to be exerting enough gravity to influence not just a single galaxy, but vast collections of them. That included our own galaxy. The Milky Way was not observing the phenomenon from a distance. It was already participating in it. Astronomers turned their attention toward the destination. And that is where the picture became difficult. The region lay behind the brightest and most crowded part of our own galaxy. Dense clouds, stars, and gas blocked a clear view. The movement could be measured with increasing precision. The destination remained hidden behind the crowded interior of our own galaxy. Astronomers could see the effect. They could not obtain a clear view of the cause. Something massive appeared to be pulling entire galaxy clusters through space. Yet the source remained hidden. The obvious explanation still seemed reasonable. If something was pulling galaxies in the same direction, perhaps the source was simply a very large galaxy cluster, massive enough to tug on its neighbors, massive enough to distort motion across the surrounding region. Astronomers expanded their surveys and pushed farther outward. The maps grew. More galaxies were added. More motions were measured. More of the surrounding universe came into view, and the pattern refused to stay local. The flow did not stop at the edge of one cluster. It continued beyond it. As the surveys widened, entire structures spread across hundreds of millions of light years appeared to share the same general movement. The motion was not confined to a single neighborhood. It stretched across a much larger portion of space. That changed the situation immediately. A nearby concentration of matter could explain a local disturbance. It could not easily explain a flow extending across such enormous distances. The farther the maps expanded, the less convincing the original answer became. What first looked like a single heavyweight pulling on nearby galaxies now looked like part of a much larger system. The observed motion was simply too widespread. One explanation after another began losing ground. The pull was still there. The destination remained the same. But the idea that one unusually massive cluster was responsible could no longer carry the weight of the evidence. Whatever was controlling this motion had to be larger, and far more complicated than anyone first assumed. Astronomers kept expanding the maps, searching for a structure large enough to match the motion they were seeing. Then the maps revealed something unexpected. Individual clusters stopped looking isolated. Filaments appeared. Then larger filaments. Then structures stretching across hundreds of millions of light years. The universe stopped looking like scattered islands. It began looking like a connected system. Within that growing network, one hidden region stood out. It was given a name: the Great Attractor. For the first time, the observed motion seemed to have a destination that made sense. At last, the mystery appeared to be shrinking. The destination had a location. The pull had a source. The scattered measurements finally seemed to fit together. The Milky Way was moving toward it. Nearby galaxies were moving toward it. Larger collections of galaxies appeared to share the same general trend. The separate measurements that once looked disconnected now seemed to fit inside a single picture. The hidden pull no longer felt anonymous. It had a location. It had mass. And it appeared capable of influencing the motion of the surrounding cosmic neighborhood. The Great Attractor did not solve every detail, but it transformed the mystery. The pull was no longer an unexplained motion without a source. It now appeared to be the natural consequence of a real structure hidden beyond direct view. And if that explanation was correct, then galaxies even farther away should increasingly reveal the same destination. The explanation held together for a while. The Great Attractor occupied the right region of space. It contained an enormous concentration of matter. Nearby galaxies appeared to be moving toward it. The maps finally seemed to point toward a common destination. Then the maps became larger than the explanation. Astronomers pushed farther outward. The maps expanded. More galaxy motions were added, then more. Then entire regions beyond the original surveys entered the picture. With every expansion, the universe looked less like isolated structures and more like a connected gravitational landscape. And the solution immediately began to break down. The flow did not stop at the Great Attractor. The galaxies kept going. The destination that seemed to solve the mystery was no longer the destination. Instead, the larger maps revealed motion continuing beyond it, toward an even more massive concentration known as the Shapley concentration. The effect was subtle at first. The Great Attractor still mattered. The observed motion still pointed in its direction. But the farther the surveys reached, the harder it became to treat it as the final destination. The maps began to resemble a landscape rather than a single target. Galaxies were not simply moving toward one isolated concentration of matter. The motion appeared connected to a much broader gravitational environment, stretching across immense distances. That created a serious problem for the earlier explanation. If the Great Attractor were the complete answer, the pattern should become clearer as observations expanded. Instead, the larger view introduced another layer of influence beyond it. The object that seemed to explain the motion now appeared to be participating in a larger flow of its own. The prediction lost some of its certainty. The Great Attractor remained real, its gravity remained measurable, its influence remained important. Yet the larger the maps became, the less it looked like a final destination. The structure that had solved the mystery now appeared to be part of a larger mystery of its own. It increasingly resembled one visible feature inside a much larger structure whose full influence was still being traced across the universe. The mystery had changed shape. Astronomers were no longer searching for a single hidden object powerful enough to move nearby galaxies. They were trying to understand an entire gravitational landscape extending across enormous distances. Every new survey revealed more structure. Every larger map made the universe appear more connected than before. Astronomers can map the motion. They can measure the direction. They can measure the speed. They can watch galaxies drifting through space and reconstruct the larger pattern those movements create. But when they look directly toward one of the most important regions in that pattern, the view begins to disappear. The obstacle is not distance, it is location. The plane of the Milky Way stretches across the sky, filled with stars, gas, and dust. From our position inside the galaxy, that dense band blocks a clear view of much of the region beyond it. The result is a strange limitation. The gravitational landscape can be traced through motion, yet some of the most important territory cannot be observed with complete clarity. So astronomers work backward. They measure how galaxies move. They compare directions. They map velocities. Piece by piece, they reconstruct the hidden structures influencing the flow. The picture becomes sharper with every survey, but it is built indirectly. The Great Attractor was never the final question. The larger maps revealed something more unsettling. Every time astronomers identified a structure large enough to explain the motion, that structure became part of an even larger pattern. The destination kept expanding. The gravitational landscape kept growing. What began as a search for one hidden source gradually became an attempt to understand how enormous regions of the universe influence one another across unimaginable distances. The motions can be measured, the structures can be mapped, but humanity is trying to reconstruct part of that landscape from inside a galaxy that blocks a portion of the view. The pull is real, the flow is real. Yet some of the most important territory remains hidden behind the place from which we observe it. The mystery is no longer what first pulled the Milky Way. The mystery is how much of the larger gravitational map still remains unseen.